joining. Okay. Thank you, Ganesh. Thanks for that introduction. And I know people are just joining, but I think in the interest of time, we'll get started. Yeah, I think it's been a interesting, time, in the industry with, the Gen AI really taking up. And today we are here to talk about a couple of topics, which is demystifying large language models and how the progression of LLMs have, going to the next frontier, which is the agentic AI. So uh, today we will talk about large language models, meaning how large language models are built, and then how the RAG solutions have, you know, complemented the LLMs to provide real-time responses as such, and even get to the next stage of how AI agents can, automate the overall process to the real next level where agentic AI comes in, which is autonomous decision making. This session is going to be, jointly done by myself and Shrija, who's our data scientist. She will certainly help you understand some of the technical details of the technical aspects of this session. And with further no ado, I would actually welcome Shrija to take it forward. You're on mute, Shrija.
Yeah. So thank you, Prashant and Ganesh. So today I'm thrilled to take you on a journey through the evolving landscape of AI, from foundational large language models to retrieval augmented generation, and all the way to agentic AI systems. We'll explore how modern AI capabilities are extending beyond just text, tapping into real-time information through RAG, making decisions with AI agents, and driving autonomy through agentic AI. Whether you're building, deploying, or simply trying to make sense of this rapidly evolving tech, you'll walk away with a clearer view of how AI is shifting from passive tools to active collaborators and what that means for the future of work and innovation. So, what exactly is large language models? At their core, they are AI systems trained on massive amounts of text, enabling them to understand, generate, and reason about human language. They power everything from ChatGPT, copilots, AI-powered search, coding assistants, and even cutting-edge tools. But how do they actually work? What makes them so powerful? And why they're such a big deal? Think of it as a really advanced autocomplete system. Instead of just predicting the next word in your text message, it understands the context, structure, and meaning at a much deeper level. Take this simple example. What is the capital of France? The model instantly processes the decision, the question, and recognizes the pattern from the training data and outputs Paris. Now that we understand what actually large language models do, let's take a step deeper into seeing what are the different stages. Yeah. So large language models are trained in three key stages. We have stage one, the pre-training. So think of it like a child learning a new language just by listening to conversations and reading books. LLMs are exposed to vast amounts of text from books, articles, and the internet, learning patterns, grammar, and factual information. But at this stage, the model is just predicting the next word in a sentence and forming the base model. It's smart, but it's not yet fine-tuned for accuracy. Here comes stage two, supervised fine-tuning. So now that we have the base model, it needs some guidance, just like a teacher correcting a student's grammar. Human experts provide high-quality answers to refine the model's responses, making them more structured, accurate, and relevant. And well, the final stage is the reinforcement learning with human feedback. Here's where things get really interesting. Instead of just memorizing the correct answers, the model learns which responses are best based on human feedback. Reviewers rank multiple answers, and the model gradually adapts by favoring higher quality responses, kind of like a student improving their answers after the teacher's grading. This learning process is called reinforcement learning. It helps the model become more accurate, fair, and aligned with human intent over time. We'll dive deeper into how they actually, work. So I'll be covering this in a quicker way because generative AI pre-training is pretty straightforward, where we have massive amounts of internet texts, books, and articles that they're fed in, and then the model is trained in order to form the base model. But it is computationally extremely expensive. So, for example, we have Llama 2 with 70B parameter model. It requires about 10 TB of text with 6,000 GPUs and up to 12 days of computational time. So just imagine that. But this is just the foundation. Pre-training alone isn't enough. We need to teach the model to respond properly, and that's where supervised fine-tuning comes in. So now that we have the base model, by training the model on massive text, here's still the problem. It knows how to answer the question. It doesn't still know how to answer questions accurately or stay relevant. This is where supervised fine tuning comes in. So it takes place in like major steps where the human asks real world questions and another human acts as an ideal AI, giving it best responses. These conversations are saved as training data, creating examples of the most accurate and relevant answers. The model learns to pair questions with ideal answers, improving its ability to respond accurately. It's like teaching a student to write great essays by showing them top scoring examples and explaining why they are good. The student learns the structure, style, and the content base for better success. Um, so now that we know what supervised fine tuning is, we have the next stage, which is the reinforcement learning. We need reinforcement learning because although supervised fine tuning ensures accuracy and relevance, but it's still limited to fixed and labeled data. Here's where reinforcement learning with human feedback comes to further optimize the model's behavior based on human preferences, contextual relevance, and ethical alignment. It allows the model to adapt dynamically, learning to generate not just accurate, but also useful, satisfying, and more human-like responses. So it goes through some major steps where you have a human providing feedback. So there's a collection of human feedback, and another human ranks these responses from best to worst based on human preferences and contextual expectations. Then we also have a ranked response. These ranked responses are then they are fed into the reward model, and the model learns to predict which responses are most preferred by analyzing the ranking patterns. So it assigns a score to each response, indicating how well it aligns to the human preferences. And the final step, so there's an optimization technique that's used, which is a proximal policy optimization technique, which iteratively maximizes the reward score without drastically changing the behavior. This approach ensures the model gradually refines its outputs while maintaining stability and coherence. So now that we have looked into the three main stages, how does the model actually understand the text in the first place? It does this by, let's look into the building blocks of an LLM. So it does this by the tokenization and embeddings. So tokenization is the process of breaking your input, which is the textual data, into smaller units like words, subwords, or characters. And this words then get these tokens that converted into embeddings. So the process of converting these words into numerical representations of vectors is called embeddings. And we also have an important technique called positional encoding. So it is very important for the model to have the order in which the words or the inputs are fed, which is why positional encoders like provide numerical values to the position for the words to be fed in. And now that now that we've seen the basic building blocks, we also need to look into its main block, which is the transformers. So the transformer consists of a two-part structure, which is the encoder and decoder. The encoder reads the input sentences and creates representations that capture the meaning and the context. It understands the input, but it doesn't generate any output. It gets fed into a hidden neural network. And then the whatever is present in the hidden layer gets taken from the decoder, and it takes the contextual representation and it predicts one word at a time using everything that's learned about the context. So how do transformers actually understand the relationship between words? There's a very important mechanism called attention mechanism. It allows the model to focus on the relevant words while ignoring the less important ones by calculating the importance of each word relative to all the other words. And this enables transformers to understand complex word relationships, capturing long-range dependencies in the context. Okay. So now that we've covered what are the major building blocks, let's look at a few examples of what are the large language models that's out there in if that's out there right now. So some of them include these are developed by major tech players like OpenAI, Google, Meta, and NVIDIA, and each of them excelling in different areas in natural language understanding. Okay, so here's a quick comparison of today's leading large language models. On the left, as you can see, there are key metrics such as token cost, speed, quality for models such as GPT-4, Claude, Gemini, and Mistral, and as well as Llama. For example, GPT-4o is fast and accurate. Claude excels in context and safety, and Mistral offers open source flexibility at low cost. And on the right, we summarize each model's strengths, weaknesses, and ideal users, helping you choose the right fit based on the business goals and the cost benefits and the technical needs. There's no one model fits all. Many companies use a mix depending upon the use cases. So now that we've looked at the different LLMs in terms of their performance, it's a natural step to understand how to make them more relevant to a specific domain. That's where domain-specific models become valuable. Instead of just relying on general purpose knowledge, these models are fine-tuned on curated data sets tailored to a particular field, whether it's finance, healthcare, or even customer service. This allows the model to be understand industry-specific language that also help in reducing hallucination, generate content that's accurate, compliant, and context-aware. In essence, it's about narrowing the gap between generic capability and model expertise. So the model not only knows what to say, but it says in a way which is aligned to professional standards and real-world expectations. Let's take a quick look at how LLMs are driving impact across all various domains. So for customer support, they help with auto triage and tickets, generating smart and context-aware replies. In sales, they analyze CRM data to personalize outreach and suggest next steps. And in finance, they summarize reports, flag risks to support decisions. And finally, in cybersecurity, they help the teams to move from reacting to proactively mitigating threats. We'll dive deeper into these use cases a bit later, but the key takeaway is LLMs are beyond just text generation and becoming powerful decision support tools across enterprises. So now that we've seen what traditional LLMs can do, but they come with a core limitation. They only know what they were trained on. That means they don't have any real-time, awareness of real-time events, internal documents, or latest updates. This is where RAG, or retrieval augmented generation, comes in. Instead of just relying solely on the model's memory, RAG allows the model to pull relevant external information in real time while generating a response. Think of it as an LLM having access to a smart search engine or a document vault. So it can ground its answers in a most trusted, up-to-date content. Let's take a closer look. So RAG is a technique that combines the power of language models with real-time access to external data. And it allows models to retrieve relevant information from connected knowledge source and then augment its response that using that context. So instead of just relying on what it was trained on months ago, the model can now answer based on current domain-specific and trusted content which dramatically improves accuracy and relevancy. Here's how it works. You have the user that asks a question, and then the system searches from the vector database or the knowledge source for the most relevant document. And then we have the augmentation technique where relevant content is passed to the LLM alongside the original prompt. And finally, the LLM provides the accurate response to the particular query. For example, if someone asks a chatbot about a company's travel reimbursement policy, a RAG-based system won't just guess. It will actually pull out the actual policy from the internal documentation, use that to inform the response. This is what makes RAG ideal for applications where information needs to be accurate, up-to-date, explainable for enterprise search, internal support, and regulatory compliance. So now the common question comes where most of the teams faces. Should we actually use fine-tuning or RAG? Well, the answer depends upon the use cases. Fine-tuning works best when you need high consistency and deep understanding with specific domain. Think of legal Q&A, clinical summarization, or even compliance reports. So all these need fine-tuning techniques. But the problem with fine-tuning, it's less flexible and it's computationally expensive. And on the flip side, RAG is ideal when you need access to up-to-date, factual, or broad information, like real-time pricing, product documentation, customer support that reflects on latest updates. It's highly adaptable since it can pull external content on the fly, but that flexibility comes with some variability in its output consistency. Fine-tuning requires more setup, but RAG is a more lighter and easier approach to implement. So let's walk through how AI has been evolving from simple LLM-powered chatbots to fully autonomous agentic systems. So we start with LLM-powered chatbots. These rely entirely on what the model has already been trained on, which is, static knowledge. So if you ask what's the capital of France, it confidently responds Paris, no external data needed. Then we move to RAG chatbots, where retrieval augmented generation comes in. Now the model isn't just guessing from training. If you ask what's the weather in Paris, it retrieves the real-time data saying it's 65 Fahrenheit and partly cloudy, much more accurate and current. Next, we enter into the world of AI agents. They don't just retrieve, they act. If you ask, find me flights to Paris from NYC under $500, the agent can pull live data from booking APIs, even shortlist the best options. It's reasoning, comparing, and presenting choices, a major leap forward. And finally, we arrive at the agentic systems where multiple intelligent agents collaborate. When you say book a business class flight to Paris under $1,000, the system not only finds options based on your preferences and past history, but it also completes the booking with minimal human input. This evolution shows how we are moving from basic Q&A generation to systems that can think, act, and coordinate complex tasks autonomously. Let's begin understanding what we really mean by AI agents and agentic systems. At the core, AI agent is a system that can take action on behalf of a user or another system. It perceives its environment, makes decisions, and performs tasks, often with minimal human support, often with human minimal input. Now we talk about agentic AI, which we will be highlighting more in depth as we move forward. So AI agent is a system that can take in users' requests, understand it, and autonomously plan, execute the necessary actions to deliver a result. What makes this possible is the combination of three components: planning, memory, and tools. Let's take an example where the human asks for holiday recommendations. The agent doesn't just pull a static answer. It understands preferences and pulls from memory, searches through available options like web search, calendars, and then recommends the tailored trip. It even considers budget, past travel history, and activities that the user enjoys. Let's see how AI agents can work. It follows a simple, intuitive flow. It starts with sense. So the agent first understands the user's input or basically its environment. Think of it as perception, where it figures out what needs to be done. Then it moves into reasoning. Here's where it breaks broader goals into smaller, manageable tasks. It's essentially thinking through the best way approach to the problem. And then we have plan. The agent lays out the steps needed to reach the goal and decides what tools or actions to use. And we finally have act, where it executes those actions by calling APIs, running workflows, or triggering systems, whatever it takes it for the job to be done. This continuous loop of sensing, reasoning, planning, and acting is what makes AI agents dynamic and autonomous. Let's quickly walk through how AI agents evolve in capacity. We start with simple reflex agents, which react to current inputs using fixed rules. It could be, like a thermostat or an automatic door. So there's no memory or learning required. Then we go into model-based reflex agents, which track past states to smarter decisions. Think of it like spam filters. And then we have goal-based agents, which plan actions to reach a goal, like chess AI, robots navigating an environment. Then utility-based, and finally the learning agents, which are the most advanced, where they learn from experience and improve over time. Think of it like Siri or Netflix recommendations. So as you move down the list, AI agents get smarter from rule-based responses to adaptive, goal-driven intelligence. Let's take a moment to zoom out and ask what makes AI truly agentic. So now that we've looked at what AI agents are, let's take a step further and talk about agentic AI and what makes them really powerful. Agentic AI refers to the systems that don't just complete tasks, they operate with a level of autonomy to pursue goals, make decisions, and adapt as they go. It works through the following core stages. They have perception, it gathers input from the world or the user. Reasoning, it interprets what's happening and figures out what needs to be done. Finally, action, where it decides the next steps and also has a learning step where it gets smarter over time based on its previous experience. If you look at the diagram here, the agent sits at the center, taking user input, using tools and APIs, tapping into any LLM, referencing data or models, and ultimately driving towards the output. It isn't just an automation, it's a goal-driven system that thinks, acts, and adapts using all the pieces around it like a digital teammate that can handle complexity of its own. As agentic AI continues to gain traction, we're seeing major tech players racing to build platforms that make it easier to create and deploy AI agents. From CRM automation to enterprise data orchestration and cybersecurity companies like Salesforce, Microsoft, Google Cloud, Snowflake are embedding agentic capabilities into their ecosystems, empowering them to automate tasks, reason over data, and take action autonomously. The message is clear. Agentic AI is no longer experimental. It's becoming a foundational layer in enterprise tech stacks. Let's talk about what's the difference between AI agents and agentic AI. So basically, there must be a lot of confusion because AI agents and agentic AI have been used very often, but there is a major difference in both of them. So an AI agent is like a reliable assistant. You give it clear, predefined rules, like fetch this data, send the email, it executes it using predefined rules or scripts. It's easy for repetitive, rule-based tasks when no decision making is required. Think of it like if this, then that logic. Now compare that to agentic AI, which acts more like a smart project manager. You give it a goal, say optimize my schedule, analyze customer churn. It can reason through the steps, use tools or APIs, learn from feedback, and then even adjust the context as the context changes. It's built to operate with autonomy, handle complexity, and make decisions on its own. So in short, AI agents are task doers and agentic AI are goal achievers, adaptive, dynamic, and intelligent. So now I will be handing it over to Prashant, who will be talking more on Narwhal's AI capabilities. Over to you, Prashant.
Thank you. Thank you, Srija. Thanks for taking that overview, and I'm sure the audience here would be technically enriched with the explanation about LLMs and how RAG and AI agents and agentic AIs are shaping up. So thanks for that. So again, adding to what Ganesh had talked about, right? As a company, we are focused on AI, right? We are actually rebranded as an AI company, which is evolving, and we certainly have looked upon in terms of what offerings that we want to cater, especially being in the service industries as such. So what you probably see here on this slide is these are the fundamental blocks, in terms of data science and machine learning, which was always there. Now today we talked about a couple of components on generative AI aspect, which is the large language models and um, the reasoning models as such, and also a little bit on the expert agents, which is the agentic RAG, and the other agents as such. So I would say, from a company perspective, we have covered the entire gamut in terms of data science, machine learning, generative AI, expert agents, and also the ML ops as such. And with companies which are probably who are setting themselves from a AI journey, and a lot of companies today that we interact with have been right now transitioning from their on-prem to the cloud um, aspect, in terms of the cloud implementation as such, which is also a key enabler for you to implement AI, in your organization. So with that is where we also help in terms of advisory and strategy with all the clients that we work with, in terms of the readiness assessment and the strategy and roadmap development. We've been actively talking with some of the clients that we are today, helping them in terms of the strategy roadmap development, technology selection, the use case identification, especially if it's a manufacturing company. How do you do supply chain management optimization, or probably the routing optimization when the goods are actually out for delivery. Chatbots, which are probably cutting across the industries as such, whether you're a banking client, you're a payments, financial services client, or any of that, chatbots and especially customer services are something which are there. So we help in a lot of those use cases and prioritizations as such. And whatever we do, we are also ensuring that it is within the guardrails in terms of the ethics and the regulatory compliance with the law of the land as such, and help in terms of performance monitoring and optimization. So overall, from an AI offering standpoint of view, we right now cover the entire gamut in terms of uh, what we have to do. And this is a quick snapshot in terms of the several use cases that we have actually solved for our customers. I'll probably specifically talk about the use cases coming up next, but this should give you a gamut in terms of how we've been using AI to enhance customer services solutions in terms of using chatbots with LLM and RAG model as such. We've also done in healthcare AI solutions where we've built uh, uh, RPA solutions and also automating the healthcare management as such. And one of the interesting use cases that I know Shrija was part of was in terms of one of the customers that we had was in the job request market. They get a lot of requirements that they had to be prioritizing and ensuring that they would go after the ones that they're feeling more confident and uh, to closure and also earn revenue for the company. So that's something. And we've also been actively working in the cybersecurity space. We did start working from doing the exploratory data analysis to come up with ML models to look into some of the cybersecurity attacks like Kerber roasting and all. And we are now helping that customer in terms of driving the agentic AI solution. So which is like always being on the continuous upward tick in terms of implementing the latest and the greatest of technology. So uh, which will help reduce a lot of manpower as such. And I did talk about supply chain optimization. and also helping in fraud detection in finance and insurance. So what I want to leave you from this slide is the use cases are plenty. It cuts across a lot of industries in the market, and we've been diversified in terms of uh, delivering these use cases as such. One thing I would also probably highlight, which she also talked about, is for us, we are a technology agnostic company, meaning the customer might have preferences in terms of the technology. They might be a Google shop, they might be a Microsoft shop, or a AWS shop, and or maybe even a Snowflake or a Databricks, anything, But for us, we understand technology, we understand what the business problems are, and we actually go ahead and solve those for our customers. And that's been our forte, and we continue to develop that expertise as such. With that, I'm going to move on. I think we've already covered this. So whatever we build, we build making sure the data is secured, authenticity is there, simplicity is there, and we enable the speed, cost, and sustainability. Most importantly, when you actually build AIML solutions, it's like a black box for people who actually consume it. So one of the important aspects is the explainability part of it, and how the ML models and the AI solutions are actually governed. So that's something that we actually keep in mind. And as I was talking about, we've had partnerships formed with all the major tech players in the market. So for us, we have that access to the latest and greatest of technologies, and that partnership really helps us to, develop these solutions in that partnership. There are a few case studies that I want to talk about relating to what Shrija has already covered. This one is more about you know, uh, the AI-driven report summarizations. One of our clients, which was in the financial sector, they had a lot of these financial reports of their clients, that they had to probably crunch through the data and understanding how their businesses were, and what would be the how to analyze that data and deliver insights so that they can make some business decisions as such. So that's where we help them build an AI solution using the uh, you know large language model, and specifically Mistral as the solution. So this again helped us in the content extractions and summarization. That reduced a lot of manual power, manpower that was required to summarize this content and deliver the insights as such. So the customer experience was also very great, and the company was able to focus on their core um, business, which was nurturing the client relationship and providing personalized advice as such. The next use case is in terms of the AI-driven chatbots, which I do believe this is something which is common across the industry. Every organization has this uh, need where they have to serve their customers better, and most of the organizations have started implementing chatbot as a solutions. So this specific one where we developed the AI-driven chatbot, leveraging the natural language processing, and uh, the impact that was done, right, was to ensure that the customer response rate, was superior, and in terms of leading to customer satisfaction, because unlike your IVR solutions, which has limited time, where you probably have 9 a.m. to 6 p.m. working hours, or maybe only 5 days a week. Chatbots are there, around the clock, and you can reach out to the chatbot anytime, and that's where the LLM and the rack solution combination, helped us to deliver this, which also uh, freed up a lot of the human agents to focus on some of the SME related things. So all the low priority ones were actually handled onto the chatbots, and even knowledge bots actually came in. Now the next thing that is probably going to be looked upon is to say how AI agents and agentic AIs can also be leveraged to solve this, which will improve the overall customer service as such. So this is another case study with respect to the chatbot. The final one is actually regarding the cybersecurity one that I was actually talking about a short while ago. Again, we started doing the EDA. We realized, how the data patterns are actually coming across, and identified how these cyber attacks actually have certain patterns based on which we developed the machine learning models. Of course, we did evaluate a couple of them and then finalized on the random forest model and delivered this. Now, the next stage that we are taking here is, while the identification classification is happening, that can be done through an AI agent, which could be again task specific and done that. But the eventual goal would be is how do I identify, how do I classify, determine whether it's a false positive or a false negative, true positive. And subsequently, let's say it is a high priority ticket. How would I also use the playbooks, that the Security Operations Center team does, look at the SOC playbook and automate even the responses, which also means now while you're using learning models to do the identification, the classification, for you to generate a response, in terms of the triaging and closing of the incident, you need, that's where the generative AI capability, which is leveraging the LLM, the RAG model, is going to be there, and that will provide the text in terms of the disposition as such. And that's how, we've been conceptualizing and, helping the client implement the solution as such. So overall, whatever we've covered in today's topic in terms of the LLMs, RAG, and AI agents and agentic AIs, those are the use cases that have been shared here so far. Just to recap the overall session, right? LLMs have been widely used applications. I think, as you could notice, in the previous slides, they probably gained traction in the last 4 or 5 years, where they've come into a lot of prominence, and a lot of them actually making it open source for developers, uh, even the business community users to actually start consuming it and start playing around with it. But then they realize there's a limitation in terms of what large language models can use because they're only trained on certain things. And that's where the enhanced AI came into picture, which is where the real-time integration, that gives more accurate responses and answers. And I would like to add here is to say, with the combination of LLM and RAGs, the solution can be made inward to an organization. So, which means if you are a financial services, company, or if you are a manufacturing company, you basically expose the data that resides within your organization, which is probably in your SharePoint, or whether it's your um, business transactions that resides in your databases, whatnot, right? Meaning give all the data and you build a rack solution on top of it. So whether it's your departmental users who actually need to get the insights, or whether it is a simple, HR, employee, who wants to understand what is the reimbursement policy, for a particular item, or maybe what's the travel reimbursement policy. Chatbots are available. They can actually fire a query and then it will give you a very specific response for that particular company, and that will make a lot more easier. And of course, you're always aware that, marketing and, some of the other contents are already using these things. But this is how really LLMs, RAG, and AI agents and agentic systems are really helping transform the industry in terms of implementing these solutions as such. Um, and I want to just close by saying, um, this is a future, meaning I would say with one of the clients that we started a project a year ago, we were talking to them about LLM and then RAG. Now we already see that, it's already moved forward from an agentic AI perspective. So the technology is very, very changing, and organizations are also kind of trying to keep up with the pace with how the advancements are happening and adapting in the specific client environment as such. Uh, yeah, I think with that, I would like to close this. And again, I know we've probably been here on time in terms of, we've probably taken a few minutes more. But if there are any questions, please post them
Yes.
in the chat window. Yeah, and then
Yeah.
we'll take
So
it
we
up.
have, thank you, Prashant and Shrija, for your insights. It was a great session. We have around 4 to 5 queries. I think we can quickly answer them. I'll request Shrija to answer this query, which is, can AI agents become agentic AIs over time with training? Is it even possible?
Thank you, Ganesh. So AI agents can become agentic AI if you provide it, memory, feedback looping. You also provide it tools. So basically, we can consider an AI agent to be a part of the agentic AI system. So if you were to make an agentic AI into, if you were to make an AI agent into agentic AI, then you would have to add in extra tools, memory, feedback loops, planning ability. Everything is required. You need to make it, uh, you need to design it in such a way that it's able to make decisions. So yes, you can convert an AI agent to agentic AI, but with extra tools, APIs that can help become agentic AI. Yeah. I
Yeah,
hope
Okay,
that
thank you, Srija.
answered your
Yeah, I
query.
hope that was the
probably want to
purpose for.
add one point there, Ganesh. Sorry.
Yeah,
Yeah, AI agents can become agentic AIs because if you look at agentic AIs, it's actually a combination of several agents, AI agents collaboratively working. While AI agent has the ability to, autonomously performing tasks, right? What agentic AIs actually really make a difference is to say how they can um, autonomously, when I say autonomously, without any human intervention, they actually start making decisions. So the moment you actually feel comfortable and confident that the agent is doing a good job, let's say, the example of flight booking, you will ask a question and you actually do it. And through the process, you learn that AI agents are doing a good job in terms of the flight ticket booking. And now you can probably make it autonomously so that it can actually go and do end to end. If there are 6 tasks or 8 tasks, doesn't matter. Meaning the n number of tasks can be completely automated. So it can be achieved, and that's exactly how the progressive is happening.
thank you, Prashant, for your inputs. Again, I think this is for Srija. Are LLMs an integral part of agentic AI for the reasoning power?
Yes, LLMs are a very integral part of the agentic power. So if you think about it, an LLM itself can be considered as an agent, like an AI agent, where you feed in the text and it gives you the output based on the queries you ask. So, how an agentic AI can use LLM is, for example, let's take a financial advisor. You would require to use LLM as a tool that can be helpful in giving out the required response or the giving out the required financial advice for a particular. So let's take an example of a stock that you're wanting to check if you want to buy or sell it. And if you feed in the stock name, LLMs can help in searching the most relevant news that's out there, like with RAG as well. It can, take in the sentiments of what exactly the stock is about. Is it good to hold, buy, or sell it? So it takes that into consideration and then the output is given. So, yes, LLM is a necessary tool for its reasoning power.
All right, thank you, Srija. Now, I think this question is for Prashant. Uh, what are some measurable business outcomes or efficiency gains organizations have achieved by integrating AI agent into their workflows?
Um, Meaning certainly, I'll probably go to the case study which was there and talk about that. Um, so if you look at, right, the business benefits are immense because once you actually have, let's say, I'll talk about the specific example with respect to the cybersecurity thing, right? So there's about almost 80% of the SOC teams uh, workload was actually triaging all the low priority or medium priority tickets. And if once you agentic AI can actually build that capability where they can independently go and do it, it is just not about triaging but also making a disposition and closing the ticket. That will free up a lot of this you know uh, human related work. So I would say it could be probably a very optimistic number of about 80%, but it's very realistic considering, where you actually apply agentic AIs and solve this problem. So it certainly varies case to case basis, but we have seen, almost very confidently, I would north of 50%, you can always be able to get productivity gains and make sure that, reduce manpower with agentic AIs. And that's basically where the world is heading, from virtual agents to being completely autonomous agents.
All right, thank you, Prashant. I will continue with Prashant. What does the future of agentic AI looks like, especially in the context of enterprise application and cross-industry innovation?
Yeah, it's a great question. I think I covered that during my discussion as such. So agentic AI is going to be transformative and disruption. So what it means is, today we just probably spoken about some of the use cases, let's say in the financial services company and, in the manufacturing as such. But if you look at today, even some of the developers actually are working, in leveraging how to develop code, in GitHub, and there is GitHub pilots as well. So the impact that agentic AIs will actually make is going to be very, very immense. And when I say immense, uh, let's say if I take a manufacturing company, right? Today, once the goods are produced and they're delivered, if I were to be sitting in the finance department of the manufacturing company, and I would actually say, okay, look at my 10 years report and, look at, do a demand forecasting and tell me what are the 3 or 5 areas that I need to focus on. Agentic AI can go and read the documents, come up with the insights and the recommendations. And if you're very comfortable that you've actually seen it, you can actually give the autonomy for that agentic AI to go and solve that problem. Okay. Which means uh, all the data crunching that is there, in a way it is good because machines are taking over the human power, but in a other way, it's also bad because the analytical things, because a human can only do certain analytical skills. So that's where it's going to be very transformative and radical change. It's going to be huge, meaning I would say that also means that, well, there's a natural inclination to say job cuts or human jobs are going to be impacted, but it will be probably repurposes for more subject matter experts and other things as such. Yeah.
All right, thank you, Prashant. I hope this answers the query. Srija, this is for you. So how we can leverage AI for testing? Do we have any use cases? And there is a continuation to that query. What is the learning path for AI?
Okay, great question. Yes, I think yeah. So there are some very good use cases for testing with LLMs where you can leverage AI. So LLMs can be used to auto-generate test cases. And now that we also have like a code, generator where it can help you code as in a particular like VS Visual Studio. So what I would say is LLMs can be useful where it can analyze the whole code and see where exactly it needs more testing required, and then it would generate test cases accordingly, or even like user stories. So yes, it can be used for you can leverage AI for testing, and path for AI learning path for AI. I hope you mean to say what is, from beginner to advanced, how you can get yourself started in. Well, I would say is to get from the basics. I know with honestly speaking, I know with all the buzzwords, LLMs, AI, everyone just directly wants to jump into what they mean, which is good to keep in, get started and like be up to date with knowledge. But if you really want to like get your hands on in AI, I would say start with mathematics, linear algebra. You go all the way to understanding supervised ML, unsupervised. Then you go try to understand what are the basics of natural language processing. How do you break the words? What are the basic techniques that's been introduced? So as you like slowly understand what's been like what are the different approaches used in the past, you will understand what are their limitations and why LLMs, AI, agentic AI has been brought up right now. So I would say always start from the base, start from the scratch, learn mathematics all the way to NLP, deep learning, and LLMs. Yeah.
All right. I think the next question can be shared between you both because it has a little bit of business angle also, I guess. So could you walk us through the biggest technical challenges in fine-tuning or deploying LLMs at scale and how teams are addressing it today?
Prashant, do you want to go for it or?
Yeah, please go ahead, Shrija. I know it's, you probably will talk about the compute and other things, but go ahead. I'll probably
Yeah,
add
this is a
if
good
I.
question. Yes, there is a big challenge in fine tuning because fine tuning is computationally expensive. Um, you require a lot of GPUs in order to basically fine tuning is retraining with your domain specific data. So it is going to be computationally intensive. So companies are going to have that issue. Then there are going to be bottlenecks when it comes to um, producing the outputs. Sometimes the problem with fine tuning is that it's not very dynamic, and sometimes it could lead into overfitting. And how companies are dealing with that is there are various techniques out there. You can use easier approaches of fine tuning, like para-efficient fine tuning, which is also like a simpler version of fine tuning. But in this case, you basically freeze the weights. Freezing the weights means you don't take into consideration of the parameters. You consider them as, I would say, randomly you consider certain parameters and certain weights, but you don't consider the whole parameters and weights like fine tuning. That is one technique. And of course, retrieval augmented generation is the alternative use where you really don't need a lot of computation. It's very light and it's much more easier to get context from the very up to date. It's very real time. So as the data keeps changing with time, you can also have your LLM provide outputs which is up to date. So RAG would be a better technique, and most of the companies are opting for RAG since fine tuning has its own disadvantages.
All right.
Yeah,
I
just
think thank you,
want to
Shrija.
add there, so if you
Yeah.
look at based on some of the OpenAI models or LLM models that are built, companies like Bloomberg and others, they actually take that and they make it domain specific models, which is where the fine tuning part comes in. So which is it by itself a bigger opportunity or a bigger space. And that's where, they only focus on financial services as such. So fine tuning and other things are more product centric and, more expensive affair. But when you want to look at it from a perspective where I have my organization's data and can my rack solution, can deliver what my business needs are, of course, the answer would be yes. And probably RAG is better suited where you want to tap into that rather than going and tweaking your LLM models until unless you want to look at it in a very different direction.
Thank you, Prashant. I think we are out of time. Quickly, we'll take the last questions, and whoever has asked other questions, rest assured we will provide the answers to those through our mail, or we'll get in touch with you and we will send you the responses. So we'll end this Q&A with one last question. This is a little, I don't know who will be able to answer this, but yeah, since the agentic AI is currently being provided by large scale companies like Google and Meta, is it easy to build agentic AI in-house and also with less data for companies wanting to use them? Since some companies have private data which they don't want to share with uh, big companies. So I hope you got it. So ideally, the question is, can we build these agentic AIs in-house and implement them? Then depending on all the big companies, is it possible?
Um, just want to be sure about the question. So, do you mean to say, large scale, okay, being provided by large scale companies like Google and Meta? Okay. Yes, you can build your own agentic system in-house. But ideally, you would still have to use the pre-trained APIs or that is present. And yes, there is concern about the privacy, data privacy. And in order for that, there are like a lot of companies like OpenAI, Mistral, that have the capability, that have like protocols, and they also kind of provide the ability for you to check out. Like you can opt out of them having data retention, or you can also opt out from a lot of other things. So using certain tools like OpenAI's LLM or Mistral AI, you can build your own agentic AI platform. You really don't have to depend upon Google AI, Google Cloud's agentic AI or Meta. You can do it from scratch. But even if you do it from scratch, you would require certain APIs, but you would have to make sure that it follows certain privacy-based security protocols. There's data encryption possible, and stuff like that. Yeah.
Yeah. Just to add in, I think I probably understood the question, and I think there are two parts here. Should we really go and build agentic AIs rather than being dependent on the industry players? The answer is yes. And again, the second part of the question was about what happens to my security. Meaning, I think there's probably a clarification required here. When we are taking models and bringing it in-house, right? And let's say we build a rack solution on top of it, right? And the AI agent is more about automating that part. What I foresee is, when you are using the model, your data is not necessarily going outside. It's not going outside. It is implemented with guardrails, associated with that. So which means rest assured, whatever that model and the rack solution that you have built, it's going to be within the ecosystem message. But there comes in a point where I don't know what was the reason of, maybe it was a clarity in terms of being dependent on industry players and building agentic solutions in-house. But I think what I want to fundamentally clarify is you don't need to be worried about the data going outside of your network. It will still stay within the network because you would have implemented guardrails. So that if that part is actually addressed, I don't think the second question whether you want to really build agentic AI solutions will come. But again, that probably gives an input for us to probably conduct another session about the guardrails and in the
Yeah.
subsequent session. Yeah, thank you for
Yeah.
the question though.
All right. Thank you. Thank you, everyone, for joining us today for this engaging session. We hope it offered you valuable insights. A big thank you to our speakers, Prashant and Shrija, for sharing their expertise on this particular topic. For your information, you will all receive the recording and presentation deck via email, and this will also be available on our website for your reference. So thank you again for being with us. We look forward to seeing you in our future webinars. Thank you very much. Take care. Have a nice day.
Yeah, thanks Ganesh and team for making this happen. Thank you.
Thank you, Ganesh.
Thank you, Shrija.
Thank you.